their product? When we multiply negative 25 by negative 1, yes. When we add negative 25 to negative 1, yes. What is the next step? What is the next step? We found the numbers, now what? What do I do with those numbers? Why did I find them? What's the purpose? Because I found them, I know it's factorable. But what do I do next? Sorry.
It's okay. I was going to say it's negative 26x minus 25 minus 1.
So we write 5x squared minus 25x minus x plus 5. Yes. We replace this quantity using the numbers we just determined. Negative 25x minus x is negative 26x.
Oh, okay, got it. Thanks.
Perfect. What do we factor out from the first two? What do we factor out from the first two? Yes, indeed, 5x. What is left in parentheses? We started with two terms. We need two terms. What we have in parentheses? This times this is at 5x squared. This times this is negative 25x.
X plus 5?
But,
X minus 5?
yes, indeed. 5x times x is this. 5x times this is this. If I do not get x minus 5 coming out from the other two terms, something is terribly wrong. It must be the common factor in the next step. Now I look. I need a sign and a factor. Do not change it into a product. You need a sign and a factor. What is it? And by the way, I know you understood the process, but if you don't practice it, you will not remember it, even if you understood it right now. Good. Sign and number, please. Sign and factor, I meant to say. This times this has to give us this. This times this has to give us this. We cannot fabricate it. It has to be there. Anybody, please? Anybody, please?
It's a negative 1?
Indeed. Good. Can anyone give us the common factor in here and in here so I can pull it out? It's right there. It's screaming back at us. What is it?
X minus 5?
That's it. And then what is left in parentheses after we remove x minus 5?
X minus 5?
So what is it?
X plus 5? X minus 1.
5x minus 1. Very good. So now we check. X times 5x, 5x squared, minus x minus 25x, negative 26x. Negative 5 times negative 1, positive 5. Okay, finally, factoring polynomials. There is nothing here. 1, descending order, so this is no good anymore. Number 2, the same thing, greatest common factor plus -1 if the leading coefficient is that. Number 3, what is it? And you will say polynomial. And number 4, nothing, no special products, nothing, nothing, factoring by grouping. That's it. That's the easiest of all. So here it is. Okay, so let's start with x cubed plus x squared plus 2x plus 2. Descending order, greatest common factor to all 4? No. Negative leading coefficient? No. The leading coefficient is 1. What is it? It's a polynomial, factoring by grouping. What will I factor out from the first 2? What is the greatest common factor to both first terms, to the first 2 terms? Anyone, please? The greatest common factor of the first 2 terms? Yes, very good, x squared. What is left in parentheses? And you have to give me 2 terms. What is left in parentheses, please? This times this has to give us this. This times this has to give us this. We started with 2 terms. We have to have 2 terms inside. Yes, indeed, x plus 1. If I do not have x plus 1 coming out from the other 2, I'm in trouble. These have to be the same. Now I uncover. We need a sign and a factor. What is it? Sign and factor. Can anyone give us the sign and the factor, please? Okay, thank you. Positive 2. Why? Because 2x and 2. Can anyone now spot the common factor that has to be pulled out? It's screaming back at us. What is it?
X plus
What is left in parentheses? Once we remove x plus 1?
x squared plus 1.
X squared plus
2.
2. Because this is out. That's all is left. It's x squared plus 2. We check. X times x squared is x cubed. X times 2 is 2x. 1 times x squared is x squared. 1 times 2 is 2. Any questions? Okay, let's work on more examples here and then we'll open Pearson. Let's say 2x cubed. Oh, which page is this? That's 8, sorry. That's 8. And we move on to 9. Good. 2x cubed minus 6x squared plus x minus 3. Good. Descending order, yes. Greatest common factor, no. These 4 terms don't have a common factor. Negative leading coefficient, no. Factoring by grouping. What can I factor out from the first 2? Anybody, please? What can we factor out from the first two terms? What is the common factor of 2 and 6? Can anyone give us the common factor of these two terms?
No.
Yes. And of x cubed and x squared? Yes, it is x squared. Very good. What is left in parentheses? Anybody?
Is it x minus 3?
So it's x minus 3. Very good. Awesome, because 2x squared times x is this. 2x squared times this is this. If I do not get an x minus 3, not fabricated, it has to be there. From the other two, then I'm in trouble. I can continue. Now I uncover. We always need a sign and a factor, mandatory. Sign and factor. What do we get? What is the sign and what is the factor? Anybody, please?
It's a sign -1.
But if I put -1 times x will not give us x. And -1 times -3 will not give us -3. So what will be the sign and the factor then? Anybody, what could it be? What times x is x? What times -3 is -3?
1.
Exactly. That's all there is. Positive. Good. By inspection, what is the common factor that screams at us that I have to pull out?
X minus 3.
Good. And after this is out completely, what is left?
X squared.
I have two terms. I have to have two terms here.
Is it -3?
Do you see the positive 1 here? Exactly how we wrote the 2x squared. The same way we have to write the positive 1. So what was in front of this factor first, and what is in front of the same factor in here? Is this clear what we're doing? You cannot, this is covered. That's why I covered up so you don't get confused. Once you take this out, what is left is this and this. You cannot make up anything. So now we check. X times 2x squared, x times 1, -3 times 2x squared, -3 times 1. Is this clear? Is that a yes? Is that a no? Maybe?
Yes.
Okay, so now I would like to, we have a few minutes left. And let me show you where these problems are. The presentation in Pearson, in my opinion, is a total mess. That's why I had to structure the factoring procedures and strategy and techniques based on what the polynomial is all about, so that you understand what we are trying to do here. Okay, so this is module 6, and as I said, is a total mess. I have yet to find one book that presents the factoring procedure correctly. Okay, so practice 6.1. Now we have everything. Now we can do everything. We know the entire strategy. Okay. Now, in this situation, for this example, because I think some of you have difficulties with the greatest common factor. So y to the 7th, y to the 5th, and y to the 8th. Let's discuss this for a moment. So if these are 3 terms, the greatest common factor, if the power is 7, 5, and 8, is always the smallest. So this is the greatest common factor, the smallest power. Because this one has more than 5, this one has 5, and this one has more than 5. So always the smallest is the common factor. So please remember that. Now, so here is just y to the 5th. Find the greatest common factor of 16x. So for 16x and 14x to the 3rd, of course, when it comes to x, the smallest power. So x will be a piece in the greatest common factor from x. And 16 and 14 only have 2 in common, because this is 2 times 8 and this is 2 times 7. So 2 is the common factor, and also x to these 2 terms. But x power 1, because that's the smallest, like here, 7, 5, and 8, I had to choose 5. 1 and 3, I have to choose 1. Good. Find the greatest common factor for this list. So here we have 18, a to the 8th, b to the 4th, c to the 5th, and 12, a to the 9th, and b. The variables are always the easiest. Why? Because power 8 and power 9, of course, it's a to the 8th, the smallest. Power 1 and power 4, of course, is the smallest, b. And 18 and 12 have 6 in common, because 6 times 3 is 18 and 6 times 2 is 12. So this will be the greatest common factor of these 2 terms. Again, the variables, the smallest power. Smallest power is 1, smallest power is 8. And here 18 and 12 have 6 in common, because 6 times 3 is 18 and 6 times 2 is 12. That's how we determine the greatest common factor. Okay. Yeah, those with trial and error, you can work on those. I just want to, yes. So for example, let's work on this one. So 18x plus 3. So these two, 18 and 3, only have 3 in common, and there is nothing else. So this is 6x plus 1. Always remember, you have to be able to recover this. So meaning 3 times 6x is 18x. 3 times 1 is 3. If you omit the 1, you will never recover the left-hand side, because you only have one term. You don't have anything else to multiply to get the 3. So if you start with 2 terms, you have to end up with two terms. Otherwise, you will never be able to say that this equals that, because one term cannot equal two terms. Good. Okay, the same thing. I encourage you to finish as much as you can between today and Tuesday. We have to review soon, and we still have an application that we didn't get to, which is solving equations. So again, these are 4 terms. We know what we have to do. So we're going to address these. Make a note on every problem that you think that we should work on in class. So what we accomplished today is huge because it's the entire strategy. So we finished 6.1, we finished 6.2, we finished 6.3, we finished 6.4, we finished 6.5, because now we know the entire strategy. And we did not reach 6.6 and we did not reach 6.7. So our test is a week from Tuesday. I hope you already registered for the test. So next week, on Tuesday, we're going to finish the application, and for the rest of the time, we're going to work on problems. We're going to review for the test. I'm sending you an old test. I would like you to take a look at it, but don't look at it before you do the homework for 6.6. For Mod 6. But